Shotcrete types. Who's done soil bed walls? Okay, that's where you're probably going to see a wet mix shotcrete. Comes in on the truck, ready mix in transit, and larger quantities is where you're more than likely going to see this. Most of the time on substructure, you're going to see dry mix. It's going to be a bag mix. We've only got one approved bag mix on the approved products list right now. It's got silica fume in it, which I'll try to remember to mention again here in a minute. So the difference on dry mix is the material is being pumped through the hose and water is being added at the nozzle. The water is mixed in at both at the nozzle and then when it impacts wherever you're putting your patch. So that's normally going to be what you see on substructure. Dry mix is, they got instant control of the consistency. That guy's got a valve. The guy that's shooting Shotcrete's got a valve controlling the amount of water that's going in that mix at the nozzle. So he can customize the mix to wherever he's shooting. He's shooting overhead or if he's shooting on a wall, whatever, he can adjust that. And there's less waste to it. Again, so we only got one prepackaged mix right now, which is a quick Shotcrete MS. It does not have fiber in it. There's also approved fibers on the APL. So if they are going to use fibers, then they will have the approved Shotcrete mix, they'll have approved fibers, and they'll mix them or not, whichever. So you place it in the hopper, they're blown through the hose, like I said, the water's introduced at the end, and the mixing is completed as the material's making impact against the other Shotcrete you shot or the back of the patch, whatever you shoot. When you have your man shoot test panel, the nozzle man is supposed to be certified. The contract calls for him to already be certified by the Shotcrete Association. When he shoots a panel, though, you want him to shoot it in the same position that you're going to be in. Now, I'm not going to, like I said, we're pressed for time. I'm not going to go through all this stuff. It's in the contract. You can read and do exactly that. But when he's shooting it, you want him to shoot it in the same position he's going to be shooting that day. If you're going to be shooting the bottom of caps, this is how he ought to be shooting his test panel. These test panels are showing they've got rebar in them. We don't require that. So he's going to be just have a panel suspended somewhere and shoot it overhead. If he's going to be shooting walls, he's going to have it propped up somewhere and be shooting it from the side. But the same position he's going to be shooting in is where the panel's supposed to come from. Rebound. This is not a basketball term. This is, especially when they first start shooting, you've got this Shotcrete mix consisting of a paste and an aggregate that is hitting a hard surface, hitting the back of that patch. When you first start out, there will be more rebounding. Rebound is basically dry rock, aggregate with a little bit of paste on it that's bouncing back. There's supposed to be a guy going along with the Shotcrete nozzle man who's got a blow pipe that's keeping things like that blown out of the way to keep from contaminating the patch. So when you're first starting to shoot, though, there's no cushion against that substrate. You got those rocks in the mix are hitting that hard back of the patch, and a lot of them are bouncing out. As you build up paste on the back of that, the rebound will decrease. And you don't ever want the rebound to be incorporated into the patch. So that's one of the things. Y'all need to be out of the truck watching all this stuff. You got to keep track of it. Overspray is a finer, it's like I won't say mist, but it's a lot finer, thinner coat of basically the paste that gets on either rebar or the substrate, and we don't want a whole lot of that either. All this stuff is supposed to be taken care of by the guy with the blow pipe coming behind the nozzle. All right, here you got the guy, he's 3 or 4 feet away. He is shooting perpendicularly 90 degrees to the patch. That's the best way to do it. Now, this mix is consolidated by the impact. It's coming out there pretty fast, and the impact is consolidating the mix. If it's coming at a 90-degree angle, that's where you get your greatest force, greatest velocity. If you start coming in at an angle, you're losing velocity. Part of it's vectoring off to the side. A longer nozzle will give you a finer stream. shorter nozzle is going to let it fan out more, which means you're not getting as much of that compaction. It's able to hit it at angles. So some of the things that you're looking for. And like I said, depending on if he was shooting overhead or if he was shooting flat work or something, he can control the water and adjust the consistency of the mix. And we're supposed to be finishing this before it sets up. He will have normally wires or something to guide him so that he is putting the proper amount of shotcrete to get back out to the dimensions that the member had to start with. And what he'll normally do is shoot a little bit beyond that. So he's got something to finish back to, trim some excess shotcrete back to get to those correct dimensions. And what he'll use for a guide a lot of times is going to be a wire. Shotcrete, like any other concrete, is subject to shrinkage. And the factors that affect shotcrete are just like any other concrete. Low water cement ratio will increase shrinkage. Thin patches, if you got an inch thick patch, big as this screen, that's a lot of surface area for it to lose water from. That's a problem. Low humidity, high winds, high temperatures, all of these are factors that can cause shotcrete to have shrinkage cracks. We're supposed to have a 7-day water cure. That's what our specifications require. What do you normally see them do when they're shooting shotcrete for curing? I wish they were, but not more. Curing compound. We are, and I think we're allowing it way too much. I'm guilty of it myself. It's hard on the bottom of a cap to wet cure something. I'll give them that. Columns, sides of caps, you can water cure that. Flat work's easy to water cure. We need to be requiring more water cure. But what they are wanting to do is spray curing compound on it. And you can end up with shrinkage cracks if you do that. What do the specifications say about curing compound? How much are we supposed to apply to a surface if we're going to use curing compound for our curing medium? At least 1 gallon for 150 square foot surface area. How many of you have ever made that calculation? Contractor brings out a garden sprayer. Have you ever measured what he's going to spray? Seen how many gallons he's putting out there? No. That's what we're supposed to be doing. And if we are going to allow them to use it on shotcrete, we're supposed to be using twice as much. Shotcrete Association says you're supposed to double your application rate if you're going to use it for shotcrete. But again, our special provisions call for wet curing, and we should be doing more of that. Why do I not like curing compound sometimes? Can you see what's going on here? Zoom in.
It's not uniform.
Look, this is terrible. When you see every little, it's been applied in a string. This is the bottom of a cap. Yeah, it was hard to get to, but this is how they did it. This is one. It's not shotcrete. This came off one of my jobs, and I stood right here, looking at this with the superintendent. Right over here, within sight, there's a Lowe's, and I'm going, guys, they sell tips over there. There's no reason for you to have this. It looked, I can't tell a lot of difference in the two. So, what is it supposed to look like? There.
It's supposed to be like a painted wall.
Yeah, it's supposed to be a.
If you do the 150, if you do the 150 square foot or a gallon per 150 square foot, it looks like you painted a wall in your house.
And if we double that, we'll have a really nice coat. Shouldn't look anything like this. Okay. This is a little bit hard to see. Normally, our samples are going to come from the panel that the nozzle man shoots at the beginning of the day. One quick note on those panels, mark your panels. If you've got a big old job, you're doing shotcrete every day, and you've got a pile of panels you've just thrown to the side over here somewhere, and some of those cores that you take out of that panel fail, and you have to go back and cut some check cores, it's going to cut the butt if you don't have them marked well and kind of laid out orderly. So keep track of them. Mark them the way you can tell where they're where it came from. This one right here, we can also take cores from the work. Most times people don't want to do that because you got to go back and patch it. But we can do that. And normally when that happens, we've had cores fail out of the panel. And we go back and core the work. Well, I've got this picture in here. This is they've cut through a piece of rebar right here, and there was a void behind it. Had no idea there was a void there until we took that core. I tried to stick a little camera back in there and get some good pictures of it, but that's about as good as I could get it. What do you do? What is our defense for this, for having voids in the patch? How do you know?
Hammer.
What?
Hammer.
Hammer? Yes. Which end of the hammer you use?
Something.
When in doubt, dig it out. First day the guys show up to shoot, you should dig something out. You see there's a sounding in, there's a digging in. Take that digging in, when they start shooting, there's nothing wrong. It's part of your job to go up there and dig a little piece out where he has shot. You're going to be, especially if you've got an area where there's congested rebar. First day, go up there, and he knows then this guy is going to check me out. This lady knows what she's talking about, whatever. He is going to, a lot of these inspection tasks become a whole lot easier when on that first day, you pull out a straight edge, you dig something out with a hammer, they know you're checking them right off the bat. Naturally, human nature is they're going to do a better job. So don't be afraid to dig something out. Be nice about it. Don't go digging something back. He's already gone to the trouble of finishing and spray some curing compound or whatever. Go right behind him. Dig a couple places out that are concerns to you. There's nothing wrong with that. It's part of your job. It's easy to shoot it back, so don't worry about it. Just do it. Okay, Shotcrete. A few things that y'all can look for as inspectors, and just signs. If the water's not properly proportioned, you might be able to tell because a really dry mix, just like if you're starting off, against the hard surface, like I was talking about, rebound's going to increase if your mix gets too dry. If it gets too wet, it may slump. I'll show you a picture of that here in just a minute. If you get it just right, it's going to have a nice little sheen to it. Not too much, doesn't look too wet, but it'll have a nice sheen to it. Again, it's applied in layers, and I've already told you about the wires that they'll try to shoot to and the blowpipe. Don't ever let the surface dry out. That's probably one of the worst things you can do on them is either the substrate, letting it dry out before you get it shot, or letting a layer of Shotcrete dry out before you come back and shoot over it. Do not allow that to happen. Sometimes down here at the bottom, cover of the steel, and hopefully we're going to get done, and Chad's going to have time to come up and tell you about problems. What are some of the reasons? One of the reasons that you see some of these repairs being necessary on columns, especially, is because when that structure was built originally, they didn't give you what? Sufficient cover over the rebar. And that's going to be some of these areas that we're going to be patching. So that's what, get this picture right here. What's this big knot? Well, we ran into a situation where that's exactly what you had right here. There was not sufficient rebar cover. If we had gone back to the original dimensions of that column, we would have been back in the same situation, and we would have had to come back and patch it prematurely. So I told them, go ahead and dig this column up so we can get at least 2 inches over it. And hopefully, even though that's not the prettiest thing in the world, that will prevent us from coming back too soon and having to deal with this column again. That's just not pretty. They're not using much of a guide, but that's supposed to be the end of the cap. It just looks like a big knob sticking out there. This is not acceptable either. There's no guide wires he can shoot to, and that's just plain old ugly. This one's one I was talking about, and it's pretty hard to see, but what happened here, this is one span, this is the other span. You're looking at an overhang here. That's the corner of the cap that got the picture. They had to chip that out. It was deteriorated and shoot it back. The first time they did it was not acceptable, so they made a special trip up, came to do some repairs, chipped that out, and they were wanting to get done that day and go home. It fell out on about 4 times because they were going in there trying to put in too much at a time, not giving them enough time to set up a bit for the next layer, and it kept falling out on them. And it ended up looking like a little butt hanging up there. There's no room right here in this joint between span A and span B for any movement of the deck, so they had to come back again. And so, some things need to be watching for. They don't need to be hurrying. They need to be doing this right. And that's just for showing consistency. Okay, acceptance. Again, we're shooting the test panel every day in the position that you're going to be applying it to the structure. 3 cores are going to be checked for compressive strength. And if you take a core out of the structure, one of the things that you're going to want to look at is that interface between the shotcrete and that base material. See what kind of a bond you've got. Sound repaired areas. You're going to be hammering these structures all the time. You want to hammer it before they remove the material. You hammer it again after they remove the material to make sure they got it all. After the patch is cured, you want to hammer it again to make sure there's no delamination or anything like that. You're going to be hammering a lot. You're going to be using your hammer to dig patches out to check their work. Again, sound all patches. I think it's a useful spot. And it is an inspector-intensive operation. And you've got to be out there with them watching this stuff. They're going to be in, sometimes the places they're working are a little hard to access. But you've got to be there, keep an eye on them during this operation. Concrete repair. Make sure you have the right material. Companies make a lot of different materials for different applications. They make repair materials for overhead patches. They make patches for flat work, like the top of a cap. A lot of different products out there. But make sure the contractor has got the right material for the patch that you're doing. I'll show you a picture of that in a minute. And read the directions. The contractor should give you some directions for whatever that material is. If he doesn't, everybody's got a website, and they have the manufacturer's recommendations on every one of these products. A lot of them have even got apps. You can, Sika for instance, you can pull up a Sika app. It's got every product, database of every product they make, with all the MSDS sheets, instructions, everything. Pull it up, make sure the contractor's got the right material, and he's using it properly. And again, can't stress this enough. For Portland cement repairs, make sure your substrate is soaked, saturated surface dry. It's got all the water it'll take, and but no surface water. That's tough. What our spec says is you're supposed to wet that substrate for 24 hours before you shoot. It's not always either possible or practical, especially when you're putting traffic control in and out, or different working conditions make it very difficult. But you should make them do the best they can. I always tell the guys, the first thing when y'all get set up is, if you're going to be shooting that day, somebody needs to start wetting patches if you don't have them wet already. Keep them wet all day long. Do the best that you can to keep those wet. This is a polymer mix. There's no water in this product. You add the liquid part A and the dry part B together, mix them up, and you're not supposed to add water. The reason I'm showing you this, the contractor was doing flat work on top of a cap on this day. This material was supposed to be used for overhead, so it was very thick and pasty material. They didn't like that, so they started adding water to it, which you're not supposed to do with this mix, in order to get it to a consistency they could work better on the top. Make sure right material for the right application. I'm not going to go very deep into this. Your water that they're using to mix these materials is supposed to be potable water. You can have that discussion with your engineer on what he considers potable water in your area.